ladies and gentlemen, boys and girls, we are going to learn about the binomial theorem. Okay? And the binomial theorem is, yes, if you might have heard this, but you thought there was no such thing as a free lunch, right? But if you binomial, then there is a free lunch, right? Okay. All right. Okay. Binomial theorem. You have to know a little bit about combinations in order to do this. And this button is on your calculator, so you can conceivably do it with your calculator. But and we are going to learn about this in the next chapter anyway. But this means sometimes it's written like this: 3 combination 1, 4 combination 2, 8 combination 7, 65 combination 15, and so on and so forth. And that comes up in the binomial theorem. All right? And so to compute these, what you do is you take this number factorial over this number factorial and times n minus r factorial, which is this number minus this factorial. Okay? How do I get rid of this again? Someone showed me. I forget.
F7.
I don't know. So for instance, if I wanted to do, these ones are kind of not nice ones, but let's say for a different example, say I wanted to do 8 combination 3, which is exactly the same 8, 3, like this. This means 8 objects. So if I were doing this, it comes up a lot in probability, but what it means is you have 8 things and you want to place them into 3 spots. And the order that you place them doesn't matter. We'll learn this in the probability chapter, okay? And we'll go into more detail on it. But as far as what it means is, so say you have 8 people and you want to choose 3 of them for a committee. So you have 8 choices for your first spot, 7 choices for your second spot, and 6 choices for your third spot. But, so altogether that's 8 times 7 times 6 different ways you can fill these exact slots. But because the order is not important, there are 3 factorial ways to arrange these numbers. So say like over here, I chose person A for this spot, person B for that spot, and person C for that spot.
That's so cliche.
Okay, but I could also have B in this spot, A in this spot, and C in this spot. Or I could have A here, C here, and B here, and so on. Altogether, there are 3 factorial ways to arrange the 3 people that I've chosen for these spots. So that's 3 factorial. So altogether, this would be 8 times 7 times 6 divided by 3 times 2 times 1. So this cancels with that, because 3 factorial means 3 times 2 times 1, which is 6. So altogether, this answer would be 56. Now, using this formula right here, which is a little bit confusing, all you would do is you go 8 factorial over 3 factorial times n minus r factorial. 8 minus 3 factorial, which is 5 factorial. And the way this becomes this is they rewrite it as 8 times 7 times 6 times 5 factorial, okay, over 3 factorial times 5 factorial, because if I continued this, right, it goes 5 times 4 times 3 times 2 times 1. But those 5 factorials cancel out, so I get the same thing over here as I get over here, I get 56. You see? So have you done this before?
Yeah.
Combinations, some of you, yes, no?
Well, like I helped my friend in geometry with this, but I haven't done it.
Okay. On your calculator, if you go to your calculator, okay, combinations can be done with your calculator, even though when you're going fast, I'll let you do this, but if I say show how to compute 8 combination 3 on your calculator, then you will have to do that. You always in front. Okay? And so to do 8 combination 3, I would go PRB, but first, sorry, I gotta do it again. Because first you want to do 8. 8, and then you go math, and then you go over here to PRB. PRB, and whoops, PRB. And then I go down here to NCR, 3, okay? And then I put in my 3, and hopefully I got this right, and I get 56, okay? So that's 8 combination 3 is 56. Now, so some of these other ones, this means 3 factorial over 1 factorial, which is defined as 1, okay? Over 3 minus 1 factorial is 2 factorial. So this just ends up being 3, right? Because it's 3 times 2 times 1, and the 2 times 1's cancel out, and it's 1 on the bottom. And that's kind of what this says is n combination 1 is equal to n. So I could have used this formula right here. For combination 2 is 4 factorial over 2 factorial 2 factorial. And you should be able to do something like that by hand. That's equal to 4 times 3 times 2 factorial over 2 factorial times 2 factorial. These cancel out, and I get 4 times 3 divided by 2 factorial, which is just 2, right? Because that's 2 times 1. So that comes out to be 6. All right, questions so far about that? Yes, sir.
Where'd you get that?
This one is r factorial. This is r, and this one is n minus r factorial. Okay. So this one would probably be hard to do on your calculator because there's a whole lot of combinations. But if I did do 8 times 7 factorial is going to be equal to 8 using this formula right here. Because that would be 8 factorial over 7 factorial times 1 factorial, right? And so this can be rewritten as 8 times 7 factorial, yes? And the 7 factorials would cancel out, so all I have left on the top is an 8 and a 1 factorial on the bottom. So this would give you our 8, or you could just know this formula. N combination n, so 8 factorial over 8, or 8 combination 8 would be 1. 8 combination 1 would be n. 8 combination 0 is defined as 1. So you kind of have to know these in order to make it work. Do I have to do this one?
Yeah.
And I'll just show you how you'd set it up. Okay. So, yeah, so that one, just to set it up, whoops, oh well. So that's 65, we can fix it, okay. So that would be 65 factorial over 15 factorial times 50 factorial, and that's going to be some big, huge, giant number, right?
Can you add factorial or like?
No, you cannot add factorials. You can multiply them. No, you can't perform operations on them.
So you just go
Not
to
really.
you just go to 50 factorial and then cross out the 50.
Yeah, your calculator might be able to handle this because it's 65 times 64 times 60, all the way until you get to 50, but then you're dividing by 15 factorial, which is a pretty big number. But that's going to be a big, big number. Wouldn't that just be 1? No.
2.07 times 10 to the 14.
What is it?
2.07 times 10 to the 14.
So Drew said this is 2.07 times 10 to the 14th power. So that's a big number. All right. All right. So why are we teaching you this? Is because it comes into this thing called the binomial theorem.
Wait, what's the
Why is Pascal's triangle here? Pascal's triangle is here because, do you guys know how Pascal's triangle is generated?
No.
You start with 1 here, and then you go 1, 1, and then you add the 2 numbers atop to get the middle number. There's always 1s down the side, okay, and at the top. But 1 plus 2 is 3, and 2 plus 1 is 3. And then 3 plus 3 makes 6, and 4 plus 6 makes 10, and 6 plus 4 makes 10. And what's interesting about there's all kinds of patterns in Pascal's triangle. But one of those patterns, if this is row 5 here, so what you have to know is that this is the 0th row, the first row, second, third row, and this is the 0th column. So this is the 0 column, and this would be the 1 column, and this would be the 0 column, first column, second column. This would be the 0th column, first column. So, like for instance, I could go down to here, this, and this is row 5, column, watch, row 5, column 0, 1, 2, okay? And this is exactly the same as 5 combination 2. This number right here. And this right here would be 6 combination 2, 6 combination 3. 6 combination 4, 6 combination 5. Wow. So we can do like 6 combination 5. Let's do 6 combination 5. 6 combination 5, I go down to the 6th row and over to the 5th column. So this is the 0th column, first column, second column, third, fourth, fifth. Okay, so I'm saying that 6 combination 5 is 6, which it is. That's 6 factorial over 5 factorial times 6 minus 5 factorial, 1 factorial, and that is indeed 6. Okay? So all of these pieces in Pascal's triangle are actually combinations. Okay? Just kind of work as one pattern. There's all kinds of patterns in Pascal's triangle that are useful in doing math. Yes, sir?
So does 6 combination 1 equal 6 combination 5 and 6 combination
Yes.
2?
Yes, very good. 6 combination 1 is equal to 6 combination 5. Yes. And 6 combination 2 is equal to 6 combination 2 is equal to 6 combination 4, and so on. So it is symmetric like that. Yeah. Okay? So why do I need to know all that? Because when you use it for expanding polynomials. Okay? So this is called the binomial theorem. And so what this is you have a variable, and this is a constant term, right? This is a constant term. You can use combinations and this binomial theorem to figure out the expansion without having to multiply x plus 2 times x plus 2 times x. So if you want x plus 2 to the 5th, you can actually use this formula rather than multiplying x plus 2 times itself 5 times, which would be a pain in the neck, or 10 times, or for finding the nth term of something like that. So it says n to the 0, which is always just n, right? Which is always just 1. And n combination 0, which is 1. This is going to be n, whatever the power is, and so on and so forth. So it's kind of better to see how this works in practice. So let's practice. When would you use that? When you're expanding polynomials. High-ordered polynomials. So for instance, say I do have x plus 2 to the 5th. Okay? If you did have x plus 2 to the 5th, that's going to be n combination 0 would be 5 combination 0 times x to the 5th n, or a to the 0. Okay? 2 to the 0, which is what? What's 2 to the 0? 1. So this is your first term. We'll get there. Okay? The next term, all that happens is this turns into 5 combination 1. This goes down by 1 to x to the 4th. This goes up by 1 to 2 to the 1st. Okay? These two things, these two exponents, always have to add up to the degree of the polynomial. Okay? So this plus this always adds up to this over here. Okay? Plus, yes, Rhoda? Because the formula says, going back, okay? Because it's not there, okay? But it's 2 to the 0 is 1, just to kind of show you, okay, what. So, where did I go? Uh-oh. Where did it go? Is this it? Okay, plus, 5 combination 2. What happens to the x?
X to the third.
X to the third. 2 to the 2. Okay? Plus 5 combination 3. X to the 2. 2 to the 3. Plus 5 combination 4. X to the 1. Right? 2 to the 4th. And then 5 combination 5, which is 1. Okay? 5 combination 5, x to the 0, 2 to the 5th. Right? And so then you want to simplify this a little bit. This is 1.
Just finish
Right?
writing it down.
This is 1. Yeah. And so what I get, I'm trying to go fast, x to the 5th plus, this is 5, this is 2. So we get 5 times 2 x to the 4th, or 10 x to the 4th. See where that comes from? This equals 5. This equals 2, right? 5 combination 2, you can look at Pascal's triangle. What is 5 combination 2? 10?
Yeah, it's 10.
10. Okay. Plus 10 times 2 squared, which is 4, times x to the cubed, okay, or 40x cubed, plus, the next thing, this is also 10 times 8, right? 2 to the third, so this is 10 times 8, which is plus, the next term would be 80x squared, right? 5 combination 3. 5 combination 4 is 5 times 2 times 2 times 2, what's it, 16?
Wait, is it 40 or 50 x cubed?
40. Okay. 80x squared. This is 5 times 2 times 2, 16, right? What's 5 times 16? 80 again?
So 160.
No, because this is 5, and this is 80 again, and 80 times 16 makes 80. 80x. Plus the last one, this is 1 and 2 to the 5th is 32. Okay, so if I were to multiply x plus 2 times x plus 2 times x plus 2 times x plus 2, I would get, when I simplified everything and made lots of mistakes, x to the 5th plus 10x to the 4th plus 40x to the 3rd plus 80x squared plus 32. Plus 80x, sorry, plus 32. All right?
And that's the final answer.
That's the final answer. All right. Ouch. So how would you expand something like this? This, the same way, okay? Except instead of putting in a, instead of using the first term as x, you call the first term 2y, okay? So this is going to look like 4 combination 0, or we're not going to do those things. 4 combination 0 times 2y to the what power? 4. Plus 4 combination 1 times 2y raised to the 3rd times minus 3 raised to the 1st. Plus 4 combination 2 times 2y raised to the 2nd times negative 3 raised to the 2nd. Plus 4 combination 3 times 2y raised to the 1st
So basically, it's the
times
same way as
negative 3 to the 3rd, plus 4 combination 4 times 2y raised to the 0, which is just 1, so I'm not even going to put that there, times negative 3 to the 4th. Okay? And so that's, and then you can simplify that, right? Hopefully. But don't forget that you have to raise the 2 to the 4th power and the y to the 4th power. And here you're going to be raising the 2 to the 3rd power, y to the 3rd power, and so on. I'm trying to get to the next thing, so that's why I'm kind of rushing. Go to the next thing. Okay, so this really ugly looking formula right here, okay, this says it's a formula for finding the term containing x to the j, okay? So, for instance, find the coefficient of y to the 8th in the expansion of 2y plus 3 to the 10th. So using this formula, it's really not that bad. Find the coefficient of y to the 8th. So in this case, j is 8, right? Because this says the term, formula finding the term containing x to the j. In this case, x is y, okay? So what this is going to look like is you're going to have a raised to the something, 2y raised to the 8th, okay? Because y, the 8th is going to be, a is going to be raised to the what?
10th.
These two have to add up to this, right? So a is going to be raised to the 2 power, but in this case, a is what? A is 3, right? So it's 3 raised to the 2y raised to the 8th, and up here goes 10, and down here goes n minus j, which is, j is 8, so what's 10 minus 8? 2. Okay? So rather than write out the whole thing, you know, and find it that way, so you could just plug into this formula, but you have to know kind of what things stand for. So this is going to be 10 combination 2, which is 10 factorial. Let me see if I can do this quickly. 10 factorial over 8 factorial, 2 factorial, yes? Which is 10 times 9, which is 10 times 9 divided by 2, which is 45. Okay? You could do that on your calculator. So it's 45, 3 squared is 9, okay, times 2 to the 8th power, times y to the 8th. And so what they're asking you is what is the coefficient? And this would be the coefficient, but you have to multiply it all out. So 45 times 9 times 2 to the 8th would be give the coefficient. Okay? Yeah? Which is some big, how much?
Oh.
Yeah, what's to the, can you multiply that in your calculator? Go ahead, David.
103,680.
103,680. Okay? Now, lastly, let's just do this one, and then we'll be done. Okay? 256?
Yeah.
No, it's not. This is 256, right?
Yeah, it's not the whole
9,
thing.
yeah, times 9 times 45. Okay? Find the sixth term. So the trick.
Sorry to interrupt. Students, today's lunch is just like Wednesday's lunch. It's associated with your fourth.
Let me just finish this last problem. So using this formula, the sixth term for this expansion, well, what's x going to be on the sixth term? What's the power of x going to be on the sixth term? Well, you can kind of, I would do it this way. I would say since this starts out at 0, right? This starts out as 2 to the 0 on the very first term. So on the sixth term, this is going to be 5. And this is going to be, therefore, what? 4, right? So that's the way I would do this. So this is going to be 9. I like to do it this way, okay? 2, the power of 2 is going to be 5, right? So it's going to be 2 to the 5th. X to the, these two have, what? X has to be what? No, the sixth term, 2 is going to be raised to the 5th power, right? Because it starts out as 2 to the 0, and then it goes up. So this has got to be 4, right? And this 5 has to be the same as down here, okay? So that's going to be 5. And then you just multiply that all out, and you'll find out what is the sixth term of that expansion. Do you follow how I got that? Because I said that when I start off my expansion, right, the first term is going to have an x to the ninth, 2 to the 0. So this is the first term, right? And so this is going up by 1. Yes? So on the second term, it's going to be something x to the 8th, 2 to the 1st, right? So this power is always going to be one less than the term that you're looking for. So if I'm looking for the 6th term, this number is going to be 5. And then you can find the other. Okay, that's it. And remember, you heard it here. And say hi to all your boys and girls, boyfriends in Disney World. Okay, bye.